Hi, I'm back, everyone. I'm back again. Sorry for the disturbance. I had a network problem. But now I fixed it so we can continue. But I wanted to do finance, but right now I don't have my calculator with me, so it will require me to do a lot of administration that will require me to use calculator. So for now, I'll just have to change a topic. I'll do trig because trig is more doable in most cases without a calculator. So it will really become much simpler to do it since I don't have a calculator with me. Theory ne, can you please tap the screen? Tap the screen. Don't be shy. Tap the screen. Tap it until your finger turns red. Yeah, today, earlier on, just a few minutes, I was doing finance, but the problem, I don't have a calculator with me, so I decided I'll do just trig since I don't have a. I can see Theorin. I can see. Thank you for the likes and others who are still new. I'm Hanani. I'm a maths tutor. Yeah, I was hoping that it's a new experience for me because most of the cases I prefer contact classes, but the world is changing. I told myself that if one day I want to be something, a part of something big, I need to learn how to evolve. So here I am again. I'm trying going the media route, online route, stuff like that. I'm hoping that you and I we can have some fun. So okay. So trigonometry. So on trig, let me change my mirror. Yeah, okay. So trigonometry is not that difficult. If you prepare it, it will be easier for you. But most important of all, it's the basics. So the basics, for you to really understand trigonometry, it's not that deep. You just need you to understand them and know when to use them, how to use them. Okay, but it's trigonometry for grade 12, but for you to understand really thorough, you need to go back to some of the basics that have been done in grade 11. So which means we're going to do the identities, you're going to do compound angle identities, going to do your double angles, but that one are for grade 12 purpose only. But for depth of it, we need to understand our angles, our likes of special angles, that will help us to understand trig more better. Okay, in terms of trigonometry, we need to understand what we call a angles. We have a type of angles, but those angles, we refer them as special angle. Now, how do we treat them, why do we say are special angles? Okay, first of all, the angles are 30, 45, and 90 degrees, and also 60 degrees. But 90 is a special case. I'll tell you why. Because 90 is part of the vertical angles on the quadrant. But I'll tell you as we go deeper why 90 is different from these three angles. But 30, 45, 60, 30 degrees are special angles, because for you to understand compound angle identity, to understand reduction formulae, expansion formulae, double angles, you need to have a pretty well studied basic of the special angles. Now, we call them special angles because when we look at our trig ratios are what we call sine, cosine, and tan, which is tangent. Now, this is our trig ratios. Then this is our special angles that combine with these trigonometric ratios, they give something that is special. Now, these angles, for them to when we combine the special angles with these trig ratios, are giving us idea of how can we get. But for us to get what we are looking for, the special angles combined with trig ratio, they give us what we call a special triangle. This special angle, this special triangle, that's where we'll deal with what? Our special angles. Now, this type of a triangle is called right angle triangle because it's mostly has what you call the height or the hypotenuse side. Most of people use it to get the side. If there are unknown side, where we use theorem of Pythagoras to get the other unknown side, or we use certain angles when we are given side. Okay, these triangles, this is what we call, we can put 30 here. Now, because this is a special triangle with a special angle, now it means we can call this triangle ABC. ABC. Let's put 45 here. Now, because this is what we call a right angle triangle, we must understand that in a triangle, any triangle in maths, any triangle, the sum of three angles added up together, they are equal to what? 180 degrees. When we add them together, they must give us what? 180 degrees. It means this angle A, this angle B, and this angle C. When we add their angles, the outcome of their addition, we should expect 180 degrees. So it means here, angle that is left is what? Is 60 degrees, because 90 degrees plus 30 degrees plus 60 degrees added up together, they are giving us what we call 180 degrees. Now remember, that's where our special angles comes in. Now, in terms of a special angle, how is our special angle and a right angle help us to understand these trigonometric ratios? Okay, this is the question we should ask ourselves. How does a right angle special angles help us to understand these trigonometric ratios. Now, where's my duster? Okay, here's my duster. If we can check here, we have sine of theta, which is a referral angle. Theta can mean any angle which is here, or here. It's a point of reference, it's a referral angle. Now we have sine theta, which is a trigonometric ratio, is equivalent to y over r, or opposite over hypotenuse. We'll talk about what is opposite, what is hypotenuse. Then we have what you call cos of theta, which is what? Which is x over r, which is adjacent over hypotenuse. We have tangent, which is y over x, or opposite over adjacent. Okay, now these trigonometric ratios, I repeat my question again. How can special angles and a right angle triangle help us to understand trigonometric ratios? Which is these ratios? The angle which is here, which is called referral angle, is the angle which is here, which is can be theta, might be theta, at most cases is theta. The angle that we are talking about in this trigonometric ratio is this one inside these triangles. Now, opposite hypotenuse, we are referring to the side. At the side of this triangle, this is the adjacent side, this is the opposite side, this is the hypotenuse side. Now, this is the side of this triangle, this is the angles of this triangle. That's how right angle triangle and special angles help us to understand these trigonometric ratios. Now, because you can see here is opposite this hypotenuse, this is y, this is r. What does opposite mean? What does hypotenuse mean? Opposite basically means the opposite side. The question is opposite side to what? Opposite, this is what? Opposite side, which is AB, which is side which is opposite to the referral angle. The referral angle is what? Is this angle. You are saying this side, which is AB, is opposite side because it's opposite to this angle. That's why it's called opposite side, or it's called y. Now, this one is called what? Adjacent. Adjacent side because it's adjacent to what? To this angle, which is a referral angle. This is the hypotenuse side because it's the longest side of a triangle, or is opposite to the what? 90 degrees angle. That's how we know this is hypotenuse. We know the opposite side is opposite side referring to this angle. Suppose in this triangle, they don't want this angle, they want this angle. Because in this triangle, we're talking about this 30. The opposite side to this 30 is AB. But in this triangle, if they say we must use 45, not 30 as our referral angle, it means our opposite side is no longer going to be what? AC, is going to be what? BC, because BC is opposite to the angle here. In a nutshell, I'm trying to say you determine the opposite side, checking whether you're working with which referral angle. For example, if they are talking about this 30, it means the opposite side is this one. When they are talking about this one, the opposite side is this one. Do we all agree? You can only determine the opposite side if you know which referral angle are you working with. Okay, it's fine. This is hypotenuse, opposite, adjacent, provided this is your referral angle. Now, this is your opposite, hypotenuse, adjacent, provided this is your referral angle. Let me erase this thing for us to understand these things properly. Yeah, now that sums it up. We talked about a right angle triangle, combination of right angle triangle and special angles, which give us a perfect identity of, give us an over umbrella view of how can we understand these ratios, because they have a relationship between the angles, which are referral angle, which is our angles that are within our right angle triangle. This opposite hypotenuse are side that are part of that right angle triangle. Okay, now let's check sine of 30, sine of 60, sine of 45 degrees. What is this equivalent to? What is this equivalent to? What is this equivalent to? In normal terms, most of when I was doing my metric, they will use a certain triangles for you to know, no, this is 1 over root 2, stuff like that. Yeah, if you want to use it, you can use it. But for me, those triangle, if in exam, you can't always be drawing that triangle for you to understand those things. You just need to know them. At first, when you do them, it's not going to be easy, but as you go on, it will be easier. It will be easier for you to remember. Sine 30 is equivalent to, sine 60 is equivalent to, sine 45 is equivalent to. It will be easier for you. Now, let's check here. Sine of 30. Sine of 30 is what? Let's start with this one. Sine of 45. Sine of 45 is equivalent to 1 over root 2. Then sine of 60. Sine of 30. Sine of 30, we can say sine of 30 is equivalent to what? Or sine of 60 is equivalent to what? Can someone tell me? Let me here write cos of 30, cos of 60, and also cos of 45. So in here, sine of 30 is equals to 1 all over 2. Sine of 60 is equals to root 3 over 2. Cos of 30 is equivalent to sine of 60. So it means it's what? Root 3 over 2. Cos of 60 is equivalent to sine of 30, which is equals to 1 all over 2. Cos 45 is equivalent to sine 45, which is the same as 1 over root 2. These things, if you must use that triangle, you can use them, but my advice is for me just to know them. As you progress with it, you'll know them by heart. You don't need to draw the triangle for 60, triangle 45, triangle for 30. It's a lot of work. You just need to know them by heart. Now, this is equivalent to this, this is equivalent to this, this is equivalent to this. Now, These are what are trigonometric ratios. Now let's erase these things. We know that cos of 60 is equivalent to what? Sine of 30 is equivalent to what? Now we have what we call co-ratios. We have our co-ratios, which is co-ratios is when we say that sine of 60 or sine of a certain angle can be expressed as equivalent to cos of a certain angle. We'll get to them. In terms of co-ratios, we are saying that we have sine of 90 minus theta, sine of 90 minus plus theta, cos of 90 minus theta, cos of 90 plus theta. Now this is our co-ratios. When we say this is our co-ratios, you are saying that a certain angle, like for example, sine 60 plus 30, 50 plus 40, 10 plus 80, 70 plus 20. As long as there are two angles, when you add them together, they give you 90 degrees. Let me repeat. As long as there are two angles, and when you add them, their product gives you 90 degrees. Sine of 60 is equivalent to, or plus, okay, let's just say sine of 60. Sine of 60 is equivalent to cos of 30. Sine of 50 is equivalent to cos of 40. Why are they equivalent? Because 50 plus 40 equals to 90 degrees. Now 90 plus 80 plus 90 equals to 90 degrees. It means cos of 90 equals to sine of 80. Cos of 70 equals to sine of 20. These are co-ratios. Are co-ratios because these angles supplement each other up to 90 degrees. They are co-ratios. Now, what do we mean when we say that? It means for me to find cos, when I have cos of or angle of sine, for me to find is equivalent of cos, I just have to subtract that angle from 90 degrees. Let me repeat again. If I have certain angle that maybe I have what? Sine of 60. Let me use sine of 60. I want it to be equal to cos of a certain angle. I use this formula. Remember I said the angle sine 30 plus 60. When I add them together, they are giving me 90 degrees because they are complementing each other. When you add them together, they are giving you 90 degrees. But sine of 60 degrees is equals to sine of cos of 30 degrees. So it means if they give me, for example, let me use, if they give me sine of 30, I'm using this rule. If they give me sine of 30 and then I want to find the sine of 30, what is its equivalent to a certain angle of cos? What do I say? Oh, this thing says when I want to find the equivalent of cos, I say sine, I say 90, then I minus that angle of sine, which is what? 30. It will give me what? It will give me what? Sine 90 minus 30, it will give me what? Sine of 60. Are we all together? But remember, we are saying that when we find cos of theta, we take sine minus 90 minus that angle. That is only when it will give us equivalent of what? Of cos. It means here is what? Sine 90 minus 30 is equivalent to what? Cos of 60. No, the reason we change this cos, the reason we change this sine to cos is because of this 90 degrees. Remember, we said that 90 is a special angle. Remember when we began at the start, 90 is a special angle because it represents a quadrant. It means in our Cartesian plane, 90 is here and 270 is here. Any angle that passes along this line has to change to another co-ratio. It means if it's sine that is in here and then it passes this 90 degrees, it must change to cos. But it's a story for another day. We just have to know that if it's sine of 30 and I want to find what is its cos equivalent, I just have to say this 30 minus 90 and it will give me, when I say 90 minus 30 will give me 60. Cos 60 is its equivalent. That's what we are trying to say here. Okay? But I know it's tricky, but we'll understand it as we proceed. But I just want you to understand that when you want to find the sine of equivalent of sine of 30 is equals to cos of 60. We are saying it's cos of 60 because we use these co-ratio formulas. Okay? It's fine. Let me erase here and write this properly. Sine of 90 minus theta equals to cos of theta. Then we have this one. Sine of 90 plus theta. But in this case, sine 90 plus theta, it gives us what? Cos of theta. We'll get to it. Now this is the formula. Then we have what we call cos of 90 minus theta. Cos of 90 minus theta gives us what? Sine of theta. Then we have what? Cos of 90 plus theta. It gives us what? Minus sine of theta. Okay? The bigger question is why? The bigger question is why sine 90 plus theta, it gave me a positive cos, but now cos of 90 plus theta, it gave me a negative sine. Let me repeat the question. Why sine 90 plus theta gave me positive cos, but when I say cos 90 plus theta, it gave me negative sine? The reason is this thing. 90 plus theta, it's second quadrant. It means is here, is 90 is here on this this vertical line. So when I say 90 plus, it means it's 90 plus something is in this quadrant. And we know that in this quadrant, sine is only sign that is positive. Tan and cos is negative. That's why we are saying that 90 plus theta, because it represents the second quadrant. That's why cos take the sign of sine in the second quadrant, because sine is positive, it will be positive cos of theta. Because in here, we are saying in this quadrant, this 90 plus theta, it means in this quadrant is second quadrant. We know that in this quadrant, cos is negative. We are saying this is negative comes from cos, because it's 90 plus theta. It changes to sine, but it takes the sign of cos in that quadrant, because in second quadrant cos is negative. It takes the sign of cos but changes to sine. Okay, so here we know that we have what? 90 minus theta. Sine 90 minus theta equals to cos of theta. Sine 90 plus theta equals to cos of theta. Cos 90 minus theta equals to sine of theta. Cos 90 plus theta equals to negative sine of theta, because what we say, 90 is a what? Is a special angle, is along the vertical x-axis, and anything that is along the vertical axis, it changes to what? Co-ratio. If previously it was sine, it changes to cos. If previously it was cos, it changes to sine, because of it's a angle that represents a quadrant. That's why co-ratio with 90, it changes to sine. Okay, now these are the basics. We are still going to do a question that will make sense when our things that we learned will start to make sense. Okay, now we did co-ratios, and then let's do compound angles, compound identities. Compound also is just formulas. You just need to understand the formulas, digest them, and remember them. So as you do them, as you go with it, you'll know them by your heart. It's not that difficult. We have what we call sine of A minus B is the same as what? Sine of A plus B is the same as what? We'll get to it. Cos of A minus B, we'll get to it. We have cos of A plus B, then we'll get to it. Now because we have this one, we'll have sine of A minus B. Now this is its compression state or reduced formula. Now we are saying this is a reduction formula because it has its equivalent when we expand it. Now we call it this reduction formula, these ones, because are more like equations that are compressed. They represent certain equations, but we'll get to them, that are called expansions formulas. Sine A minus B is equivalent to sine of A cos of B minus cos of A sine of B. Now this is equivalent to this, but this is the expansion state. The question can say, they can give you something like this and expect you to expand it like this, or they can give you something like this and expect you to go backward and reduce it to this. You must not look at it in one way. It's a two-way route. Is implied by. If this is equivalent to this, also this is equivalent to this. You must be open-minded and bear in mind that sometimes they can give you something like this and expect you to go here, and give you this and expect you to go here. Now, the one with sign, the one of sign, the middle term of the reduced formula, the sign remains the same regardless of whether you expand it or you reduce it. Then we have sine of A times cos of B plus cos of A times sine of B. Remember, this is sine. The sine of the compressed formula or reduced formula is the same as the expanded formula because it's what is sine. Remember, with sine, the signs remains the same regardless of the sign. But when it comes to cos, the formula changes a bit, but also take the reverse sign. So if it's negative, when you expand it becomes positive. When it's positive, when you expand it becomes negative. And the reverse is the same. When you reduce them, when it is positive, the sign take the reverse sign. So here with cos, we have cos of A, cos of B. Because it's negative, we have plus sine of A times sine of B. Then here we'll have what? Cos of what? Cos of A, cos of B, minus, because here is positive, sine of A times sine of B. And then the formulas are there in your formula sheet. Things that are written here, you have them, are there in your formula sheet. But what I want you to understand is that you need to know them by heart, because when you know them by your heart, it saves you a lot of time. I'm Hana Letonolo. Today's topic is trig. If you are still new here, can you please subscribe and tap the screen? So I was saying that what I want you to understand is that you need to know them by heart, because it saves you time, and when you save time, it means you maximize marks. Because what is the point of you knowing things but you take time knowing them? It means in your exam paper you will not finish, and if you don't finish, it means it's a problem, because if you don't finish, you'll get low marks. Now, I want you to understand the pattern between the ones of cos and the ones of sine. If you can check here, the ones of cos and the ones of sines, they have two differences. The two differences is that the ones of sines, they start with sine A cos of B, and then they take the same sign as the one in the brackets. The one of negative, take the sign of negative, and we start with sine of A and cos of B. Cos of A, sine of B. But the one of cos, they always start with cos A, cos B. Cos A, cos B. But they take the opposite sign of the one that are in the bracket. That is the difference between the one of cos and the one of sine. So, if you can see, you have them in your formula sheet, but I just want you to understand the difference. But this is compound angles. Previously, we did co-ratios, and we did special angles, and we did a right angle triangle. But for you to understand the trigonometry, you must able to what? Integrate or combine together the usage of compound angle, special angles, and also what? Co-ratios. That's why I started by separately showing them separate. so that when we combine them, it's going to be easier for you to understand them, or so that they can make sense to you. Okay, now this is compound angle. Let's have a practical example and see how can we understand it. I'll give you a chance for you to tell me what you think, but for now I just want you to understand the basic, because in maths everything always revolves around the basic. If you don't understand the basic, that's the problem. It's never about the number of questions you practice. It's never about the number of hours you spend practicing. Those are important, but the most important above all is, do you understand what are you talking about? That is the most important thing, and understanding comes from the basic. Okay, now let's have a practical example. We have what they say, sine of what? Sine of 75 degrees. They want you to find the value of 75, sine 75 degrees, cos what? Cos 105 degrees, and what? Sine 50. Now they want to find this, the value of this, without the use of a calculator. Now, the first thing that we do, we ask ourselves, we cannot answer questions of compound angles if we cannot identify special angles. Now remember, what are our special angles? Our special angles are 30 degrees, 60 degrees, and what? 45 degrees, and also 90. 90 in this case is extra special. Let's leave 90 for now, because 90 is extra special, because 90 requires you to change, because when you change, we can also agree that change is a big thing. Everything that requires you to change is difficult. No, 75 is not a special angle, but it's a question that they requires us to answer when they say sine of 75 degrees. I will get to it, but for now I want you to understand how can we break 75 in terms of special angle. Can we break 75 in terms of special angle? We'll get to it, but I want you to understand that change is something that is difficult, because it requires you to change habits. It wants you to change how you think. If it has to do with going to a new place, it means you have to move, you have to adapt, you have to meet new people, you have to learn new languages. That's why we say 90 is extra special, because it talks about change. 30, 45, 60, they are special, but they are not special to the level of 90. They are special, but not extra special. You see, it's like 90, it changed the whole things, but 30, 45 and 75, they don't change a lot, but it's a change. Okay, now the bigger question, how can we break 75 into special angle? Can someone write or tell me how can we change or break 75 into special angles? Why specifically special angles? Because you can only use compound angle formulas when we can identify special angles. Can we change 75 into special angles? If it's a no, say no. If it's a yes, say yes. Can you please say yes or no in the comment section? Theory. Okay, because it's the first time we are still introducing. I will give you a pass on this one, but I need you to engage. Tell me what you think so that we can help another. Remember, we are all learners. We are here to learn, and does not mean because I'm the one facilitating this session, I'm always going to be right. And you can show me something, I can learn something from you, and I can teach you something, and I can learn something from you. Now, if we can check what our special angle are what? 30, 45, and 60 degrees. Now, if we can check, 75 can be broken into special angles. Sine of 75, when we instead of saying sine 75, we can say sine of what? Sine of 45 plus 30 degrees. Lester, very good. So it means 75 can be broken into 30 and 45. Now we can now see that, oh, now 45, 30 are special angle. Because 45 and 30 are special angle, that's when we can use compound angle identities. It means sine 75 can be broken into sine 30 plus 45. Okay, then remember, because we have indication, or we have identified that we have special angles, it means now we can what? Expand, because this is sine of A plus B. Remember the ones that we did for sine. It means when we see sine plus A into brackets, you can either expect us to expand them or reduce them, because you can see this one that is inside the bracket. It means the necessary step, or the right step, or recommended step in this one, it means we can what? Expand. So it means we can write this as what? Sine 45, because in this case 45 is our A and the 30 is our B. Sine 45 times cos of 30. Remember, the one of sine, always take the same sign as the one that are in bracket, plus cos 45 times sine of 30 degrees. So we can see that, okay, let me write it properly so that you can see it very well. So for now, let's erase this thing. We can write it as what? Sine 45 cos 30. It takes the middle side, cos 45 sine of 30. Remember, ne? Now, because you can see that we used 75, that was not a special angle, and break it into the angles that will give us a special angle. Why do we do that? We do that because we want to what? We want to use compound angle identities, because one of compound angle identities requirement is for us to have special angles. Now, because we have a special angles, we can say, because this is sine 45, we know that sine 45 is equivalent to what? 1 over root 2. Cos of 30 is equivalent to what? Cos of 30 is equivalent to what? Root 3 over what? Root 3 over 2. root 3 over 2. Then we have plus cos 45 is what? Root 2 over 2. Sine of 30 is what? 1 over 2. Then we check again. Okay, since when we have expressed our sine 45, cos 30, cos 45, sine 30 into its equivalent. So remember, is where we use those triangles, but those triangles are not necessary if you know them. But now you just have to write them down. Just know this is equivalent to this. As you go on, you'll know them. Now, because we have this thing, because this is multiplication, then we say 1 numerator multiplied by numerator, denominator multiplied by denominator. 1 times root 3 is what? Root 3. Then we have what? Root 2 times 2, we'd have what? 2 root 2. We'll have something like this. Plus, we have this one. This one plus this one. We'll have 1 over root 2 2 over root 2. Then we come here again, we check. Okay, if we can check, we multiply this thing by this thing. We just say 1, which is a numerator, multiplied by root 3, it gives us the top part. We say root 2 multiplied by these 2, because these things are not like terms. This is under the radical sign and this is not under the radical sign. We just multiply them together. The same applies here. 1 times 1, it's 1. Okay, we come here. Then we check here. Because we can see that here and here, if we can check this and this thing, they have what you call common denominator. Our bottom part in my left and my bottom part in my right have the same values. They are all over 2 root 2. And also here is 2 root 2. It means it's a what? It's a common denominator. If it's a common denominator, it means I can write this as 1 plus root 3 all over 2 root 2. This is how that's how we know that we have we can find the value of sine 75. For you to understand, or for you to really get what's going on, or if you want to check whether you are correct or not, you just have to say on your calculator and sine 75 and press equal to, and it will give you its equivalent. It will give you somewhere around this thing. Because they say without the use of a calculator, that's how we did it. Remember this root 3 over 2, you have used those triangle, right angle triangle for 30, 40, 45, stuff like that. Now, let's recap. They said we must find the value of sine 75. We find it. we express it in terms of special angles. We saw this is a reduced compound angle. Then we expand it into special angles. We got this, multiply them together. They gave us this. Then we saw that we have a common denominator and express it as 1. That's how we did this. Okay, let me erase this one. And then it means you can do sine 15 and cos 105. So I want you to try it. I don't expect you to be perfect, but what I expect you to do is at least put an effort. And put an effort, it means you must try. Because the only way to get things correct is by learning, and by learning is by trying. So if you learn, you'll get better. When you get better, you'll save time in your question paper, and when you save time, you'll maximize the marks. And when you maximize the marks, you will pass. And when you pass, you'll be happy. Then this is sine of 15, this is cos of 15. I want you to express it in terms of special angles and those steps that we did there. And for you to tell me what you think, comment below. If you are new to my channel, can you please subscribe and follow and tap the screen. I'll give you 5 minutes to do it. Belum kosong. Oh, I'm back. I'm back. So we had what? Sine of 15. Then sine of 15 can be expressed in terms of what? Sine of 15 can be expressed in terms of sine of 60 minus 45, or sine of 45 minus 30. Why these two? Because sine 60 is a special angle, 45 is a special angle. 60 minus 45 will give us 15. 45 minus 30, 45 is a special angle, 30 is a special angle, will give us what? 15 when you subtract them. So it means this one you can expand using this one or expand this one. So it means for this one we'll have what? Sine of 60 times cos of 45 minus cos of 60 sine of 45. Then here we'll have root 3 over 2 times 1 over root 2. Then here we'll have cos of 60. Cos of 60 is the same as what? 1 all over 2 sine 45 is the same as 1 over root 2. Then we do the same thing. The numerator multiplied by numerator. Root 3 times 1 to give us what? Root 3. Then we do the same. Denominator 2 times root 2, because they are not like terms. This is under the radical sign. This is 2. This is 2 under the radical sign. We multiply them. It becomes 2 root 2. Then here 1 over 2 times 1 over root 2. 1 multiplied by 1 is 1. 2 multiplied by root 2, 2 root 2 is 2 root 2. Then we check here. The numerator, the denominator and the denominator, they have the same base. They all have 2 root 2. It means it's a common denominator. We can write it as what? We can write it as 1 plus 1 negative 1 plus root 3 over 2 root 2. Can we all understand it? If you get it, write W in the comment section so that I can see that you get it. Write comment W. If you get it, write W. Or W. You gotta get a W. W ya o tše pedi. So lerara last ke yena wa go nkwa I one bana. Okay, it's fine. We move on. Whether you use sine of 60 minus 45 or you use 45 minus 30, it will result you to the one same answer. Does not matter. What matters is, have you used the special angles? Have you used compound angle? Have you used to determine these things without the use of a calculator? Were you able to find the value of sine 15? That's what matters the most. Okay, let's move on. Let's find other interesting questions. So that becomes easier for us. Okay, they say we have another example. The sine 169 times sine 41, and also plus, let me check it, okay, plus sine 79 times sine 131. Sine 141. Let me write my handwriting. Yeah, okay, let's look at it. We have sine 169, sine 41 plus sine 79, and also we have sine 131. If we can check here, we have 169, 41, sine 79 plus sine 131. It's a question for a compound angle, but we have to understand that compound angle, when you have a compound angle, we have the one for sine and the one for cos. And the one for cos is the one that deals with, it starts with sine. The one for cos start with cos A, cos B, sin A, sin B. The one of sine start with what? Sin A, cos B, cos A, sin B. That's the first thing that we need to understand first. So if we check here, we have 169, 41, sine 79. The first thing first that we can do before we can change whether sine to cos or cos to sine, we check, we have to pair the angles. What do I mean when I say we have to pair the angles? We have to check that those angles, when we add them together, those angles must give us what? A special angle. That's what we want, because remember, a compound angle can be only found in a special angle. Even the same applies, even a special angle can be found in a compound angle. It means the first thing that we must do first, we must try to pair the angles. Like here I have 169 and 41, and I have 79 and 131. I check the two pairs that I need to change. You see, I have 41. Then I ask myself, which angle do I need, or do I need to add or subtract from 41 to give me whether 60, 45 or 30, because those are special angles. You choose. Then first thing first, I check if 41 and 79, if you can check them, are the two angles that are below 90 degrees. And if are angles that are below 90 degrees, it means for now we can leave them, because it means we have to find other angles that we can add to them, so that they're giving us what? Compound angles. Even 90, we also saw that 90 is a special angle. Then we check here 161. How can we find 161? If you can check 161 is the same as, then you can check here, is either I change this 2 sign to be, or I change this sign to be cos and change this one to, if I change this 2 to be cos, it means I'm taking the compound angle of what? Of cos, of sine, because of sine is the only one that says sine, cos, sine. But if I change this 2, it means I'm taking the compound angle of cos, because the compound angle of cos is the one that says cos, sine. Then I check first. Let me pair the angles first. Then I ask myself, sine 169. How did we find 169? Okay, how did we find 169? We can see that sine 169 is the same as 180 minus 11. Then we remain with sine 41. It's okay. We leave it, and we have sine 79, because 79 and 41 are the angles that are below 90 degrees. For now, we leave them. My handwriting is big. Let me reduce them. Sine 180 minus 11 is the same as 169. Sine 41 and what? Sine 79. 131 can be expressed as what? Sine 180 131 is sine 180 minus what? 49. Are we clear? Now we check again. Sine 180 minus 11 is in the second quadrant. It means we drop 180, because 180 represent which quadrant? So we have sine 11, sine 41, sine 79 times sine 49. Now we reduced our angles from the bigger angles to a smaller angles that are below 90 degrees using reduction formula. Now we have sine 11 degrees, sine 41 degrees, sine 79 degrees, sine 49 degrees. Then we check here. You choose the two combination that you want. It's either 79, if you can say 79 plus 11. If you say 79 plus 11 is give you 90 degrees, which is a special angle, or you can say 49 sine 79 minus 49. It will give you what? 30 degrees. Or you could say sine 41 minus 11, it will give you 30 degrees, which is the same as special angle. Let's say we take 11 and 41 so that they make a special angle. So we say that, okay, because I take sine 11 and 41, it means I have to change sine 79 and 79 and sine 49. Then I say sine 11 sine 41 plus 79 can be written as sine 90 minus 11. Sine 49 can be written as 90 minus 41. Do we all agree? Sine 79 can be written as 90 minus 11. Sine 49 can be written as 90 minus 41. Do we all agree? Okay, we come here. Sine 11 times sine 41 plus, this is 90 minus 11 is co-ratio. It changes to what? Cos 11 times, this is cos 90 minus 41. It changes to what? To cos. Cos 41. Do we all agree? If you can check, we have sine 11, sine 11, sine 11, sine 11, or sine 11, sine 41 plus cos 11 times cos 41. Because here the sign is is addition. The sign here is plus. I can easily change how I want to write them. I could start with cos 41 cos 11 plus sine 41 times sine 11. Sine 41 sine 11. I just rewrote the same thing, but I just change it in a way that will make sense. Like here, this is cos 11 times cos 41. If I say cos 41 times cos 11 is the same thing. 3 multiplied by 2 and 2 multiplied by 3, the answer is 6. Does not matter. Then even here, I can either say sine 11 or sine 41. Because here's a multiplication, it does not matter. Whether I say sine 11 times sine 41 or sine 41 times sine 11, it does not matter since what is multiplication. Even here, because it's positive, if I can say 5 plus 2 is 7, if I can say 2 plus 5 is 7, that's why I took these things, put it here, and these things, put it here. Because when there's addition and multiplication involved, the order does not matter because they give you the same answer. But if it was a division or a negative, the answer is not the same. You only do that when you have only multiplication and addition. For example, 4 divided by 2 and 2 divided by 4. Because you are dividing, the other one is 2, the other one is 1 over 2. It's not the same. But when you multiply, when you multiply 2 times 2 is 4. When you add them, 2 plus 2 is 4. Whether it's 5 plus 2, 7, 2 plus 5, 7. But 5 divided by 2 and 2 divided by 5, the ratios are not the same because it's a division. In the subtraction, 5 minus 2 is 3, 2 minus 5 is minus 3. Those things are not the same because it's subtraction and division. But with multiplication, order does not matter. Okay, because you are here, then we rearrange our ratios in a way that will have a heading and will be able to understand them and will make sense to us. I have 2 criteria here. I have cos, sine, sine. And then it means the compound angle of cos is the one that starts with cos A, cos B, sine A, sine B. Do we all agree? Okay, and then our angles also, we have A, which is 11, which is 41, and B, which is 11. A, which is 41, B as 11, and then 41. 41, because it's cos, we say that the of course, when you expand them, when you go back into the brackets, you take the opposite side. It means it becomes cos of 41 minus 11. Remember, why is here positive, here is negative, is because when we expand cos, it always take the reverse sign or the opposite sign. When you expand it, cos 41 minus 11, it will be cos 41 times cos 11 plus sine 41 times sine 11. Do we all agree? Then we come here. Because we are here, then if we press our calculator, cos 11, cos 41 minus 11 is the same as cos 30 degrees. Do we all agree? And then we know that 30 degrees is a special angle, and then cos of 30 is the same as root 3 all over 2. Now we have proved, we have used a compound angle to come up with a special angle. Can you please tap the screen and subscribe to my channel? We are doing trigonometry. We started showing co-ratios, compound angles, and also how to expand and reduce compound angles. In this question, we were required to use co-ratio, which is changing sine to cos, and also making sure that we change our angles using complementary angles or co-ratios, making sure that our sine 75, they change using 90, and making sure that we reduce the expanded expression into a single trigonometric ratio to have this and equal this. So guys, This is how we use special angles and co-ratios to understand compound angle identities. Here we'll meet tomorrow again. For today, it's just the basic stuff. Tomorrow we'll continue. It means tomorrow when we continue, we'll start with double angle, and we also have the identities. And then when we have the double angle and the identities, we'll be able to do the trick, the one of sketch and the one of proving the left hand side equals to the right hand side, and the one of 3D and the one of what do you call them, the one for question 10, the one we use the maximum height, the one that is always a tricky question in paper 1 that requires you to differentiate stuff like that, but it's fine. For today I wanted you to learn the basics of how we can use special angles to understand how to write or express compound angles. Can you please subscribe if you want to learn more? And then you also there's also a room for improvement, and there's also a room for a critique, and also a room for appraisal. And then, as I told you, that I'm not perfect. I'm here to teach you, and you're also here to teach me. I can teach you by showing the things that will help you to understand trick. You can show me appreciation by correct me the things that you think I'm not doing well, or the things that you, or the way you think I should do. Ka mokgwa o naganang gore nka improve gona, le ka mokgwa le gore o nagana gore nka dira gore o kgone go nkwešiša ka gona. So for today, I think we are done. Thank you for your participation, especially you, Lasta. Shout out for you. So tomorrow, yeah, guys, we'll continue. As I said, it's my first time doing the online session. Most of the things I'm doing contact classes, so I'm trying to learn or to transition from the contact to online, because we are moving in a world where when you don't know the social media, you end up becoming incompetent. Hey, so tomorrow around this time, around 3 o'clock, we'll do this again, and I hope that we can able to participate the way you did today. So this is it for today.